Hi everyone, this is the Maths with Adam, and today we will talk about the labs of indices. The first is basically just the rule of the indices. If we have a number and we raise this to a power, then we will multiply the number by itself as many times as the number in the power. So 3 to the power 4 is 4 times 4, 3 times 3 times 3 times 3. So a to the power m, it's m times the a, a. If we divide two power, two indices with the same base, then we take away the powers. So 3 to the power 5 divided by 3 to the power 3, it's 3 to the power 5 minus 3, so it's 3 to the power 2. So, and this is why. We know that the fraction line also mean division. So 3 to the power 5, it's 3 times 3 times 3 times 3 times 3 divided by 3 times 3 times 3. So we can just simplify, and this will be 3 to the power 2, so 9. Here is also a little sketch. Okay, and here is the formula. If we raise a fraction to a power, then we will raise the numerator and the denominator. So the top and the bottom number, okay? So it's 2 to the power 2 divided by 3 to the power 2. If it's 5, then we will write it's 5 and 5. And we can just calculate. And here is the formula. If we multiply two indices with the same base, then we add the powers. Okay, so 2 to the power 3 times 2 to the power 2, it's 2 times 2 times 2 times 2 times 2. We can see we need to add the powers. And it's 32. And here is the formula. If we raise something on the 0, okay, so 2 to the 0, it's 1. A to the 0, any number is 1, expect the 0. The A cannot be 0. If we raise to the 0 to the 0, it's non-exist. Okay, so it will be basically error on the calculator too. Here is how can we raise if we multiply two number and we raise this the power, then we basically just 2 times 3 times 2 times 3, so this is the 2 times 3 to the power 2, and we can make the groups 2 times 2 times 3 times 3, it's 2 to the power 2 times 3 to the power 2, so it's 4 times 9. So we raise the members here, terms in the bracket. Okay, so a times b to the power m, it's a to the power m times b to the power m. Here is the formula. If we raise something in a negative number, then we will first write the reciprocal and raise the number in the denominator on the power what we raised. Okay, so basically 5 to the power minus 1, it's 1 over 5 to the power 1. 5 to the power minus 2, it's 1 over 5 to the power 2. A to the power minus m, it's 1 over a to the power m. And a cannot be 0 because we cannot divide by 0. If we raise a number to the further, if we raise a power to the further power, then we multiply this to power, because 2 to the power 2 times 2 to the power 2 times 2 to the power 2, so it's 2 to the power 2, and we raise this to the power 3, it's 2 times 2 times 2 times 2 times 2, okay, it's 2 to the power 6. So basically nearly everything we can solve everything with basically just this. And after we use the algebra and just, okay, like this, it's really tricky. We need to know how can we do this, but yeah, okay. And here is the formula: a to the power m times, and this to the power n, then a to the power m times n. And this is basically how can we write the root into power form. Okay, so 2 to the power 1 over 4, it's fourth root of 2 to the power 1. A to the power 1 over m, it's mth root of the a. And this is, if it's not 1 over something, 2 to the power 1 over 4 equal fourth root of the 2 to the power 5. So the denominator will come here, and the numerator will come here, sorry, and the denominator will come here. And also here is the formula, you can see. And, we will just solve some problem. I didn't delete it. Okay. I worked a little on it, and I needed to record. So 10 to the power 3 times 10 to the power 4, it's 10 to the power 3 plus 4. We multiply two indices with the same base, then we will add the powers. So it's 10 to the power 3 times 10 to the power 4 equal, like this. Ten to the power 3 plus 4, it's 10 to the power 7. We again just add the powers minus 5. So it's 3 to the power 10 minus 5, because plus and minus sign together is minus. 3 with 3 to the power 5. 10 to the power 0 times 10 to the power 3, it's 1. So 1 times 10 to the power 3, it's 10 to the power 3. Or if I just add them, it will be the same. If I divide two indices with the same base, then I take away the powers, 9 to the power 2. If I divide two indices with the same base, I will take away the powers. Okay, so don't forget this, we need to take away the minus 6 from the minus 4, and it will be plus because it's smiling. Okay, so it's 3 to the power minus 3 plus 6, 3 to the power 2. If I raise power to the further power, I need to multiply them. So it's 5 to the power minus 2 times 2. 5 to the power minus 4. If I raise the power to the further power, I need to multiply them. Minus times minus, it's plus. 2 times 2, it's 4. Okay. Work out and write back. Okay, 4 to the power minus 1, it's 1 over 4 to the power 1. 5 to the power minus 2, it's 1 over 5 to the power 2. 16 to the power minus 4, it's 1 over 16 to the power 4. 5 to the power 1 over 2, it's 5 to the power 1, and we take the square root. 7 to the power 3 over 4, it's fourth root of the 7 to the power 3. Okay, and we will write back. We can see it's 3 to the power 2, and this is a reciprocal, so it will be minus 2. Sorry, I will just clean. Minus 2. Okay. 1 over 3 to the power, 1 over 4 to the power 3, it's 4 to the power 3, and we can see it's minus 2 to the power 1 over 2, and here's the base will be the 3 to the power 7 divided by 5. 7 over 5. Okay, evaluate. Next one, it will be trickier. Okay, as you can see, this will be the last problem, this 2, and after we will talk about the lots of roots. So, if I have a fraction and I raise this to the power -2, then I will just raise the numerator and the denominator. But this is -2, so it's mean it's 1 over 4 to the power 2 divided by 1 over 9 to the power 2. So basically I divide the 1 over 16, 1 over 4 square divided by 1 over 9 square. So it's mean I divide something by a fraction. It's mean I will multiply by the reciprocal. 1 over 4 to the power 2 times 9 to the power 2 divided by 1. And we can see it's 9 to the power 2 divided by 4 to the power 2. 8 times 8, it's 81. 9 times 9, sorry, it's 81 divided by 16. And I think we cannot simplify this one. Okay, next one. It's not so hard. It's 1 times 10 to the power 2. It's 10 to the power 2, it's 100. Next one. Minus 3 to the power 2. If I raise a negative number on a even power, then it will be positive, because minus 3 times minus 3. It's minus times minus, it's plus, 3 times 3, it's 9. What happens if I raise minus 3 times minus 3 times minus 3 to the power 3? It will be minus minus plus times minus, it's minus, times minus 3 plus minus plus. Okay, so this is how it will work. So it's plus 9 times, and first I can take the reciprocal and after rise to the power 2. So the reciprocal of the half is 2 over 1, so it's 2 to the power 2. 9 times 4, 36. And we can see here another problem. 2 to the power 3 plus 3 to the power 2 divided by 3 to the power 1. So we can simplify here. Plus 2. So 2 to the power 3 is 2, 4, 8. Plus 3 to the power 2 divided by 3 to the power 1. So I will take away, it's 3 to the power 1, so it's 3 plus 2. And if I add these 3 plus 8, it's 11 plus 2, it's 13. And this is the final answer. This. Okay. I put here a star because it's some extra. Okay. As you know, I use a book, but it was not in the book. I just wanted to practice a little bit basically the fractions. I add them, so 5 to the power 1 over half times itself, it's 5 to the power 1 over half plus 1 over half, and we will just add the half and half. It's 5 to the power 1, so it's 5. We just multiply them. We multiply by a whole number of fraction, then I multiply the numerator. So 9 to the power 3 over 2. It will be 9 to the power 3 under the square root. Okay, it's 9 times 9 times 9. It's 81, 91, sorry. 91 times 9. 72. Sorry. Okay, I will be honest, I don't know it's a square number or not, so I will use my phone and calculate it. It's 27. Okay. Oh, of course, we can calculate other way too. Okay, I will show you how can you calculate without a calculator. Oh, sorry. So it's 9 times 9 times 9. And we can take the square root just like this. Okay? Because if it's like I raise this to the power 1 over 2, so it's 3 times 3 times 3, and it's 27. And we don't need to use the calculator. Never mind. We just can solve like this. Okay, next one. It's 27 to the power 2 under the cube root. So the 27, it's cube root. It's 3 to the power 3 times 3 to the power 3. And we can just write like this the roots, the cube roots, and it will be 3 times 3, so it's 9. Okay, so I will just explain with this like this. Okay, we can just disconnect basically this big one square cube root. I will write it down. So it's equal with this. No, sorry, it's 2. Yeah, okay. But no, sorry, mistake. 27 times 20. No, it was good. Okay, sorry. 27 equal 3 to the power 3 times 3 to the power 3. Okay, sorry. Mistake. And it's correct. So it's 3 times 3. It's 9. Okay, next one. I divide two indices with the same base. I will take away the powers. So it's 4 to the power 3 over 2 minus 5 over 2 equal 3 minus 5. It's minus 2 over 2. If I take away a fraction, another fraction, then, and the denominator is the same, then I need just calculate with the top number and write down the bottom number without any change. So it's 4 to the power minus 1, because minus 2 divided by 2, it's minus 1, so it's 1 over 4. And the last one, I multiply, I need to add. If I multiply two indices with the same base, I need to add the powers. 12 to the power 5 over 20 plus 4 over 5. If we add two fraction with not a common denominator, we need to find the common denominator. It will be the 20. And we will check how many times go the 5 into the 20. It's 4 times, so I multiplied by 4. I also need to multiply by 4. If we search a common denominator, we need to find a number what I can divide by the starter numbers, denominators, okay? Oops, sorry. No, okay. So I just add them. 12 to the power 21 over 20. And it's like this. I will not calculate this if you don't mind. And I don't know, the calculator can handle this big number, but it doesn't matter. And loves of the root, basically it's a little bit same as the loves of the indices, because they are really common things. Okay, so mth root of the a to the power m, it's equal with the a. This is what we used here and here too. Mth root of a to the power n, we can basically just write the n under the power. Okay, and write this. If I multiply the root, then I also need multiply the power under the root, and it will not change the value of the question. Okay, this is what we use here. If I have a multiplication under the root, we can just open it into two roots and multiply them. Okay, it's like I have this 1 over m. I raise this 8 times b to the power 1 over m. It's the same. I rise a fraction into 1 over m. It's the same. I rise something or the power, further power, it's the same. Just the powers, it's 1 over n times 1 over m. Okay, this is how it's work. And this is something really special. We not really often use this. Okay, so it's, if I, basically it's we search a common denominator here. Okay, so I raise the power m to the a, power n to the b to the power n, and I can multiply the two roots, n times n. And this is also not really often used thing. But if you write everything back to indices, then it's much easier. Just figure it out, the things with the fractions. Okay, this is for today. I hope you liked it, and see you in the next video.